Hello wonderful person, this is Anton, and today we're going to discuss another somewhat unnerving study that essentially focuses on various hazards of satellite megaconstellations. Thousands of proposed satellite networks that are trying to improve internet communication with the eventual goal of having up to 50,000 satellites in low Earth orbit pretty much at all times. And though obviously Starlink by SpaceX is the most famous one, we know that other companies like Amazon are actually planning their own as well. But this new study explores what happens to these satellites once their mission is over and once they return to Earth. And it is maybe a little bit scary, because in this case it involves the ozone layer. But I guess first, a few side notes. There was actually another study a few months back that explored potential dangers of these megaconstellations when it comes to the magnetosphere. And in that study, though somewhat unnerving as well, it was basically projecting for maybe a few decades ahead, when we have like thousands or even millions of satellites that in theory could start producing a lot of particles that can actually start affecting magnetosphere to at least some extent. You can actually learn more about this in that video in the description. And so there, it was not an immediate effect and not something you're going to be observing for at least a few decades. In contrast, this new study has discovered something that's a little bit more immediate, with the effects even being a little bit more dangerous. Because here we're talking about the ozone layer. And that's actually important because whenever we talk about various extinction events, for example the ones caused by supernova, the biggest danger is always the disappearance or the depletion of the ozone layer. For example, one of the extinction events approximately 400 million years ago revealed potential UV damage in a lot of different seeds and a lot of different pollen, implying that a lot of radiation was reaching the surface, very likely because the ozone layer has become depleted by something else. And here, a massive supernova nearby is one of the potential explanations. There's actually another video in the description that talks about that as well. But when it comes to depleting the ozone layer, surprisingly, humans found an extremely effective way that's technically even more efficient than any supernova nearby. And here I actually wanted to briefly mention a very good article from CNN you can read in the description that basically talks about Thomas Midgley, also known as the man who almost destroyed the world twice. And he was basically a chemist who essentially invented CFCs, or chlorofluorocarbons, previously used in refrigeration or even a lot of fire extinguishers, but apparently, because of their stability, a lot of these gases end up reaching the upper atmosphere and then become really effective at destroying ozone. And so if it wasn't for the 1987 Montreal Protocol that basically banned these substances from planet Earth, the ozone layer by now would be almost non-existent. But luckily for us, the ozone holes have been sort of healing and might recover in the next few decades, with the current calculation suggesting about 50 years. You can actually explore one of the NASA links in the description to see how it's recovering and how we measure all of this pretty much every day. But because of all of these studies and because of so much research when it comes to ozone layer, we actually understand the chemistry pretty well. You can read this by yourself in one of the links in the description, but in essence, the loss of ozone is usually the result of so-called free radicals. Basically atoms or molecules with some kind of a free electron. And they actually initiate these cycles that eventually destroy many different ozone molecules with just a single atom of, for example, chlorine. And most of these radicals are formed when a lot of different gases are broken up by UV light somewhere in the stratosphere of planet Earth. So for example, one famous gas is nitrous oxide, a typical greenhouse gas usually produced by microbes, but also produced by various agricultural activities. And so that gas is also a type of an ozone destroyer. Another more common gas is actually based on water vapor. And luckily for us, water vapor doesn't usually make it that high in the stratosphere unless something major happens on the planet, suddenly releasing a lot of water vapor all at once. And one such recent example was of course the eruption of Hunga Tonga underwater volcano. This released a lot of water in the stratosphere, which potentially decreased the ozone layer by at least a little bit. But it's really the chlorine-based and bromine-based compounds, or basically those CFCs, that usually damage the ozone layer the most. Mostly because they create cycles that can easily destroy many molecules over and over and over again. But luckily for us, they are eventually expected to come down into the lower atmosphere, mostly because most gases and aerosols usually stay in the stratosphere for a maximum of 6 years. This is because of various air circulations that eventually bring everything down to Earth. But what about this new study? Well, it's actually focusing on something entirely different. Something that is coming from outer space, and something that once again we are kind of responsible for. And here we're talking about massive amounts of satellites currently orbiting the planet. Interestingly, out of approximately 8,000 objects in the low Earth orbit, 6,000 are basically Starlink satellites. And by design, in order to avoid becoming space junk, they're supposed to re-enter after about 5 years. But also, by design, they actually contain certain compounds that are somewhat questionable. And one of these compounds is aluminium oxide. And so the researchers in the study decided to see what exactly aluminium oxide might do in the upper atmosphere, and most importantly, if it might have any effect on the ozone layer as well. With the overall conclusion being that the ozone layer might actually stop recovering and once again produce more ozone holes. But here the focus is of course on the re-entry, or the burn-up of satellites in the Earth's atmosphere. Here's actually a really intriguing picture taken by Scott Kelly that essentially shows us a leftover plume from the re-entry of the Soyuz capsule that obviously produced some particles left behind in the stratosphere as well. And so as these satellites burn up in the atmosphere, the researchers here worked out they obviously leave behind a lot of metallic particles, with a typical satellite potentially generating about 30 kilograms of aluminium oxide particles within just a few minutes. And so once they calculated the total amount for all of the re-entries in 2022, they came up with a number of about 17 tons. But naturally, as the satellite networks grow in size, they actually estimate this number to go up to about 360 metric tons every single year, with most of this aluminium being injected anywhere between 50 and 85 kilometers in altitude, staying there for possibly a few decades, but then basically eventually making its way toward the location where the ozone layer is, drifting down to stratosphere in about 10 to maybe 30 years. And so in other words, we're not going to be seeing effects tomorrow, but we might start seeing these effects in 2 to 3 decades. But the question is of course, what effects, and can it be actually dangerous? Although first, I guess let's put this in a perspective. The Honga Tonga volcano released approximately 50 million tons of water in just a few hours. But here we're talking about only 360 tons over a period of a year. So in some sense, maybe it's nothing to worry about. However, when it comes to various atmospheric aerosols, which actually do play a role in ozone destruction, previously about 10% of aerosols contained aluminium. But the new prediction suggests that it's going to increase to about 50%, very likely causing a dramatic change in aerosols, producing a lot of cold reflective particles that can actually create tiny surfaces for this type of chemistry to take place. And so in other words, the main suggestion here is that they basically act like catalysts. They're going to dramatically increase the destruction of ozone without causing actual reactions themselves. And because they're catalysts for chlorine activation, as long as we have any CFCs produced on planet Earth, CFCs plus satellites re-entering Earth can potentially create a very destructive process leading to a major ozone hole disaster. On top of this, they might also interact with various acids, including sulfuric acid, resulting in even more complex chemistry that's currently barely understood. Mostly because this is something we've never seen before, and something that typical volcanoes don't actually release into the atmosphere, and so we don't know what to expect from any of this. And though obviously stratosphere already has a lot of metals from various meteors burning up in the upper atmosphere, most of them don't contain aluminium oxides, and so we don't really know what's going to happen. Fun fact though, that sodium layer you see, that's actually the result of meteors forming a kind of a dust layer that's visible from outer space. And so I guess the scary part here is of course if nothing changes. If megaconstellations grow in size to about 50,000 satellites and continuously deposit more and more aluminium oxide particles that in about 20 to maybe 30 years finally start affecting everything. And since this is not the first study to address this, this is definitely something that concerns a lot of scientists. And so I guess what's the possible solution? Well, first solution is obviously more and more studies, modeling, simulations, or even attempts to study the upper atmosphere directly just to see what's happening with aluminium oxide and how this might change the ozone layer in the future. But second of all, well, maybe SpaceX, Amazon, and other companies can start making satellites from different materials. For example, recently there was that story from Japan where a Japanese company decided to launch a satellite made entirely out of wood, and that is maybe one of the possible solutions, even though it does sound kind of cheesy. But if it works, this could be a very easy fix just by replacing aluminium oxide with something that's a little bit less destructive. And since the effects from this might only be visible by 2040s, 2050s, and will actually be visible every single year after that, by then it might be too late. And so yeah, a somewhat scary but also somewhat intriguing study that helps us reflect on the effects we're having on the atmosphere and reminds us to maybe not to get too arrogant, or I guess having too much hubris, before we cause even more damage to the planet. And so on that note, once there are some additional studies, or once something else is discovered on the effects of satellites on planet Earth, we'll come back and talk more about this in some of the future videos. Until then, check out the previous video that talks about slightly different effects, subscribe, share this with someone who loves learning about space and sciences, come back tomorrow to learn something else, support this channel on Patreon by joining a channel membership or by buying the Wonderful Person t-shirt you can find in the description. Stay wonderful, I'll see you tomorrow, and as always, bye bye.